from just opening NetBeans, you're going to go to File, New Project, and then we're going to make a Java class library. I'm just going to name it Basic. Choose whatever folder you're going to put it in, and then hit Finish. On the left side here, your source packages, that's where all your code is going to go. If you put the drop down on the folder, this default package, you're going to right click it and you're going to hit New Java Package. Inside the Java package, the naming convention always starts with com.yourname dot the name of your project. So in this case, I'll name it tutorials.basic. Hit Finish. Once you have that, you right click that and hit New Java Class. I'm going to name that class Application Start. It's automatically going to add it to the package since we right click the package. You hit Finish and then you have your Start class. Right now we have this application start, and in here you see the application start.java. If we try to run this right now, if you right click on the Java file and you hit run file, it's going to give us an error because our application doesn't have a main method. The sole purpose of a main method in Java is to be able to run your application, right? Your application won't know where to point to at the beginning. It's like the constructor for your application, right? How do you define it? And we'll go over this later. Just know that this is for every Java application. The start line to define it is public static void main string open bracket close bracket args. So don't worry about too much about the syntax right now. Just understand that this is a constructor for your application, right? So after you have this, you hit save, and then now if we go to application start and you hit run file, it's going to tell us the build was successful. Nothing's happening, but our application ran now that we have a main method. The first thing I'm going to go over is in JavaScript. If you want to write to the console, you write console.log, right? In Java, we're going to use system.out.println some message, same thing, right? So now if you save it and you right click and hit run file, I think the command to run your application is Control-R. And then if it asks you that your application hasn't defined a main class, it should automatically show your application start, and you can select that. So if I hit Apple R, it's going to bring me to that screen. Project Basic does not have a main class set. You just select the main class and hit OK. So now you can just run it with Control R or Apple R if you're on a Mac. So here you'll see that it prints out to the console now, just like how in JavaScript you write console. So now that we have a main method that acts as the constructor for our application, right? I'm going to show you how to write a constructor for a class. I'm going to leave this application start just to solely have the purpose of initiating your application. I'm just going to leave it like that, right? A main, and I'm just going to remove everything inside here so our application is able to start. And then I'm going to right click here again, or just hit Control N, new Java class, right? If you hit Control N, it's going to just select here Java class. In this new Java class, I'm just going to write demo. I'm going to hit finish, and it's going to automatically bring whatever your template says. So again, this is our applications constructor. Now we have a new class. We already have a main method defined for our application, and now we're just going to define a constructor for our new class demo, right? To make a constructor, you just define it as public and then the name of your class. right? This is a constructor. Constructor is some method that will get executed as soon as your class gets instantiated. And we'll go over instantiation right now. So now if you save this, then you just have public class demo and public demo, right? Which is our class constructor. We save it and we're going to go back to application start. And inside of our main method, which is the constructor for our application, we're going to write demo, our new object equals new demo. Okay? We're going to save that, and then inside our demo.java class, in the constructor, we're just going to write system out print line demo instantiated. All right? So now when we run the file, you should see in your console output demo instantiated. This is instantiation. You're instantiating a class. This the main thing to note with this is that in JavaScript we write var our new object equals. We can either call a function, write a function, or we can write something, right? Var our new number equals 33. For now, I'll just stay with strings and integers. In JavaScript, we don't have to define the type of object that we're creating, right? Everything's a variable, everything's var. The same thing with a function. A class is a function, this is a function. It's completely different in Java in that you have to define exactly what it is, the type of variable that you're instantiating, right? So in this case, we're making a variable an object of type demo, right? If this exact 2 lines, the equivalent in Java, since the first one is a string, we're going to put string our new object equals some string, right? And then the bottom one, since it's a number, we can write integer int our new number equals 33. This is giving me an error because we. Yeah, well, yeah, string is a capital S, and then the int is lowercase int. Those are fixed words, declarations. So this is basic variable creation, right, in Java.
Now let me ask you this: if you instantiate the demo Java class, right?
Yeah, right here.
Now it's always going to call the constructor function, or you can call our method that you want on that class.
Yeah, it will always call this constructor function if it's defined. If you don't define this constructor, it's still fine over here.
Okay. So it still have the object already.
Exactly. You can have no constructor. It's automatically going to create one for you. Then it's going to run your default constructor. That's what it is. And if you define some method inside your class, you're still going to be able to call it once you instantiate it. Some method. There it is. Right? So you can still call it without having to define. You don't have to define your constructor. But if you do, it'll always run that default constructor.
There's no reference to the actual demo Java class. Is that just because it's part of the same package?
Yes, that's because we've defined up here on the first line. It says package whatever, right? We have the same exact name inside this demo.java, so that it will automatically. You don't have to import this. You don't have to import the class. It's that's how packages work. Another thing on constructors, if you don't define one, it automatically generates the default one, right? If you do define one, then that will be the default, right? If you define another one that accepts, say, an integer 10 and a string, some string, right? Again, when you're passing variables, when you're defining parameters for functions definitions, it's the same thing like how variables are created. The difference between JavaScript and Java, right? Here you just write variable and whatever can drop in there, it's an object. The same thing with if you write function demo, some int and some string, that would be fine in JavaScript, right? The same thing with creating variables is the same thing with creating functions that have parameters inside of them. You have to define a type, and you have to define a string.
Int 10.
Do you have to
Oh, sorry, I put int 10.
on this
Int,
record,
some
you
int.
have-
If you want to return something from your method, you would write public, and then here the next word is the return type, right? So if you're returning a string, you would type return string, public string, get some string, and then inside here you would return. So we'll go back to here. We have another constructor defined, right? And we're accepting an integer, some int, and a string, some string. We also have this defined, which is another constructor. This on the top, since it doesn't have any parameters being passed into it, is called default, right? Default constructor. And then this one will get called if when you instantiate your class, you pass an integer and a string inside the constructor, then this one would be called. So just to demonstrate that, I'm just going to put system.out. Demo second constructor called, and then in the default, I'm going to put system.out println default constructor called. So now if we go back to our application start, I'm going to remove all this. Demo some objects equals new demo, right? That's going to call our default constructor. And if we put demo some other object equals new demo, and we pass it an integer and a string, then when we run the file, it's going to call the default constructor when it instantiates this object, and then it's going to call the second constructor when it instantiates this object.
So it can be the same name. How?
Yeah, that's it's called overloading the constructor, but it's just if you wanna instantiate this class with different parameters, parameters set at the construction level, right? Another method of doing this is if you, just to demonstrate that you can call stuff inside constructors and chain them, you can, if you call the default constructor, which is going to get executed when we instantiate this object, right? Yeah. Inside the default constructor, we're also going to call this, so we're going to chain it. For that, we just write this, and then 10 and some string, right? So then now if we run the file again, the second constructor is going to be called first because this is in the first line of the default constructor. And then after it executes that, it's also going to call the default constructor, right? So that's just chaining and constructor overloading. So public and private variables, right? We already went over that if we're just defining a variable of type string, we just put string, some string, right? This is a local variable inside the constructor. What a public and a private variable is that a public variable is accessible by everybody, right? And a private variable is only accessible to members of the same class. Okay, so all the public and private, all your class variables gets defined. If you have a constructor, it's in between the constructor and the class definition. So right after the class definition, we're going to say public pdemo, right? We're going to give it a string type equals hi, I'm public, right? We're going to define it up here in the top. So once this class gets instantiated, this will automatically get, this value will automatically be assigned to this pdemo variable, right? So if we go back to our application start and we're instantiating the class into this object, some object, we're automatically going to get access to that public variable that we defined in there. If we type some object and you put period, I think on PC it's control / you're going to get access all the accessible members and variables in there. So here you see that the pdemo is accessible to you. That p object, pdemo that we define as public, The reason it's showing up here is because we defined it as public. So we can put it system.out print line someObject.pdemo. Okay, and then when we run our application, it's going to run it and it's going to retrieve the value of that public variable. If we define another variable right under it and we define it as private, and we make another string, PVT demo, this variable right now is only going to be accessible to members of this class within here. So if we try to do the same thing of typing some object and then bringing down our dropdown, we're still only going to see our pdemo object, and that PVT demo, which is defined as private, is not going to be accessible, so it's not going to show up here. Right? That's basically the definition of what public and private variables are.
What about if you define a property or variable inside the constructor function?
Inside here,
Yeah. Do you have access?
if we define
Like a bullet.
No, we don't have access. The constructor has access, and that's it. That's the scope of it. The scope of it within the function is between the brackets. Now, if you're putting it outside of the
You
constructor, then it's obviously available to any of the functions within it.
yeah, inside here, if you're inside the constructor or any method, you can't define your variables as what this is. The public and private is called an access modifier. You can't define it inside the methods, the method body. You can just say string hello, and then once you do this, it's localized into this constructor. Exactly.
That is your scope for that variable. So you can have another variable called hello, string hello on a different function, and it will not matter because they're in different scopes. You guys get that?
Like that. See, we're writing what he just said about we have a string, a local variable named named hello, and then we have another local variable named hello inside this method. These the scope of them are within those methods, so you can't access them again if you instantiate this and you try to access them. They're not gonna come out. We have access to the P demo, right? Because we've defined it as public. If we want to get access to this private demo, we will make what's called a getter, right? If we put public, we have to make it public because it has to be accessible, obviously, right? Public get PVT demo. Right now, we need to specify a return type, right? If we're gonna get something, and the naming convention for getters and setters will always be get, and then your variable name starting with a capital. So in here, we're going to define that this, since private demo is a string, we're going to say public string get private demo, right? This is the return type. And then in here, we're just going to return PVT demo. So now when we go back to our application start, if we type some object, we look at the methods that are available, we're going to see get private demo, and the return type is a string, right? So if we log that to the console, so again, just quick review, the public string pdemo is public, the private string private demo is private string, and we just made a getter that's returning a type string, and it's returning our private variable. Application start, we're just logging to the output, we're calling someObject.getPrivateDemo, and then when you run that, it should say from the first console log, you have your public variable value, and then the second line would be the private variable value. The main thing to note about public and private access modifiers is that if you're gonna have a method inside your class that you need it to be accessible outside of the class, you're gonna define it as public. If you only need that class to know about it and it's just gonna be run from within your class, then it's gonna be private. Don't ever define a variable as public, class variable. If we have this constructor as a public demo, and then we need to do something to initialize something or to do something inside this class that you don't want outside access into it, then you can call it inside here, I'm private method, right? And that's going to execute now inside it, since we're inside the class. You're able to call it, but still you're not going to be able to call it from outside it. two more types of variables that you can have. The main ones are final and static, right? If you define something as being final, then what it is that it can only be assigned a value once. After you assign that value to the variable, it cannot be overridden, right? That's what a final is. So if we put a public final string final demo,
Maybe like having a constant, right? Constant value.
You have to define the type and you have to, the type of the variable, right?
here
You
is
can
public.
see it can be integer.
In here,
Yeah.
yeah. If we put an integer int, then we could put 22, right? So I'm gonna leave it as a string. Again, the public is the access modifier. It's available outside this class. Final means that since we're assigning the value to it right here, this value of this variable cannot be changed again. So since it's public, again over here, some object can be accessed, final demo. But it being final, if we try to change that inside any method anywhere else, it's gonna flop. So final demo equals changed, and it's gonna give you an error, right? That error is that you cannot assign a value to final variable final demo. That's what a final is, right? Another thing on final is that since we're defining we're assigning the value of it right here, right? If we don't do that and we just create the variable, right? This is what's called a blank final. That means that in the first line of your constructor, final demo equals, now I'm assigned and can't change. That's valid, right? Because
That's
we're
the
just
first time that it's assigned.
exactly. The other one is static. We just instantiated demo sum object equals new demo. Okay, we're gonna write another one, demo another equals new demo, and then demo keep going equals new demo, right? Say if we wanted to track how many times this demo class gets instantiated, that's when we would use an example of a static variable. This static string that we define here, static demo. Just for example, I'm gonna make it an integer, and I'm gonna assign it 0, right? So now in our constructor, every time that this class gets instantiated, we're gonna increment that static demo variable by 1. Okay? So now if we run this, and then in the system out for the default constructor, and then we just print out the static demo variable. Once we run this, the static variable will automatically increment and not reset back to 0 with each instantiated object, as opposed to this, where if we define a private variable of a type integer, every time that we run this constructor, the not static will increment by 1. But if we instantiate 3 of these objects, each of those instantiated objects will have a not static private integer of 1, since every time we instantiate the demo class, it will reinitialize a private variable starting at 0. Just to demonstrate that a little bit further with what Brian just asked, is that if we make an if statement, static demo is 3, right? Then we're just gonna system and then now if we do this, we're just gonna write keep going 2 and keep going 3. Now when we run this, you're gonna see tuk 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 boom. It's gonna reset it however many times you want it to reset. That's static. Another thing to mention on that is that right now here we're instantiating the class into these objects, right? we don't have to do that to access static variables or methods. We can call directly system out print line demo dot, and then you're going to see your static demo variable in there because it's part of the class. You don't have to instantiate the class. So now just really quick to review the main parts that we went over. Just try to make a class that accepts a number in the parameter in the constructor and just prints that number plus 5. So the simplest way of making a class that accepts a number as a parameter in the constructor and prints the value of the number plus 5 would be to create a constructor, right? And then we're going to set a parameter in there of type integer. And then we can just put system.out print line num plus 5, and that will do what we need, right? So then if we go to our application start and we say demo, objects equals new demo, and we pass in 5, then when we run our program, it's going to print out 10.